Hi students, once again I welcome you all to my channel Abrar sir classes. ಇವತ್ತು ನಾವು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಚಾಪ್ಟರಿನ ಲೆನ್ಸಸ್ ಲಾ ಟಾಪಿಕ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡೋಣಪ್ಪ. ಫಸ್ಟ್ we will learn what is meant by Lenz's law. This is the explanation of Lenz's law. What it is saying, an induced current always flows in a direction such that it opposes the change which produced it. This is a magnet, okay, or magnet, which is brought near this coil. Okay, what happens, the coil repulses the magnet. Okay, ಇದು repel ಮಾಡಿದಾಗ the same polarity will be formed here, because we know that like poles repel, unlike poles attract. Okay, therefore you will be having north pole here. North pole andre, okay, now the direction of current will be in anti-clockwise direction appa. Okay, that you have to remember. That is very very important. Okay, this is what, like this, anti-clockwise. This is north pole. Here the magnetic field will be outside itra. Okay, this is direction of current. Direction of current, anti-clockwise direction, anti-clockwise direction. Okay, now here the magnet is away from the coil. Away, if it is away, okay, the coil attracts the magnet. Attraction andre this will become south pole. South pole andre this is south pole appa. Okay, okay, this is south pole. Okay, yes, pole, okay, of the magnet. Okay, now here the magnetic field will be inside. Okay, understood. Now here it will become south pole. Direction of current is what? In the clockwise. Direction of current is what? Direction of induced current is clockwise. Clockwise direction. Understood? Clockwise direction. See the galvanometer here. Okay, it is moving to the right side and it is moving to the left side. It shows deflection. Okay, but here the deflection is in the opposite direction, because the current is in the what? Here anti-clockwise direction, Ilian is a clockwise direction. When the bar magnet is brought near the coil repels the magnet. The coil repulses the magnet. Therefore, same polarity is found here. Okay, north pole andaga, as soon as you think of north pole, you should remember what? Direction of current is anti-clockwise direction. Illi bandaga, when the magnet is away from the coil attracts the magnet, so it becomes south pole. The direction of current will be in the clockwise. Understood? Now here, now come to conducting loop. This is a bar magnet. This is no current is flowing in the loop. When the direction of movement of the bar magnet is towards nearer the conducting loop, what will happen? Okay, here north pole, okay, will be developed. North pole andre, okay, if you know north pole, the direction is what? The direction of current is in the anti-clockwise direction. Okay, anti-clockwise direction. Okay, induced current is induced current. in the conducting tube. Now if it is away, it is towards, okay, towards the bar magnet is towards the conducting tube. It is away. Away, what happened? The conducting tube tries to attract it. Okay. Therefore, which pole is produced here? South pole. South pole andaga, which one? It is in the clockwise direction. Okay. It is I induced will be in the clockwise direction. Understood? Now this is the concept. We will try to do the sums. This is the very first sum. Figure shows planar loops of different shapes moving out of or into a region of magnetic field which is directed normal to the plane of the loops away from the reader. Okay, now here observe this one. Okay, observe this one. Okay, it is coming towards the field. Okay, once if it is coming towards the field, area is increasing. Okay, area is increasing. What happens if area increases in the first case? If area increases, what happens? Flux also increases, because we know that phi is equal to what? Phi is equal to B upon. Okay, phi is directly proportional to what? A. Okay, what happens? See here, I have written one note here. Please make a note of it. Area inside the region of magnetic field increases, flux increases. Coil will try to decrease flux by producing field which is in opposite direction. Now here, what is the direction of magnetic field here? Okay, I have told you this is what? Inside. This is what? Inside. Right. Which pole? Andre idu south pole. Yes, pole. Okay. Yes, pole. Yes, pole andre clockwise. Right. Clockwise. South pole. This one is outside. Outside. Outside andre north pole. Alenappa. ಇದು ಬಂದು clockwise. ಇದು ಬಂದು anti-clockwise. N pole, north pole. Right. Okay. Now here, what happens? Area increases, flux increases. Now coil will try to decrease flux by producing field which is in opposite direction. Opposite direction, which is the opposite of south pole. That is north pole. Okay, this is the north pole. This coil will try to decrease flux by producing field which is in opposite direction andre. So it will produce what? North pole. Now in case of north pole, what is the direction of current? It is in the anti-clockwise direction. Okay, it is in the anti-clockwise direction. Okay, anti-clockwise direction. Okay, induced current is what? In anti-clockwise direction, because it is coming towards, okay, itu towards the field. Second, it is what? Away. Second is what? Away. Away andaga what happens? Area is decreasing. Flux also what? Decreases. When flux decreases, the coil produces what? Second case. Okay, flux decreases. Coil will try to increase flux by producing field which is in same direction. Same direction andre this will produce what? Again same field. Okay, which is called S pole, south pole. Now we know in case of south pole, the direction of induced current will be in the clockwise direction. In the clockwise direction. Okay, this is what? I induced is what? Clockwise appa. Achanappa. This is only the concept. Now it is away. Away andaga ಏನಾಗುತ್ತೆ? This is fourth case. Okay, I have taken the fourth case. Here A is decreasing. Flux what? Decreases. Flux decreases andre same polarity. Okay, same polarity. Same polarity means south pole only. In case of south pole, it is clockwise direction. It is clockwise direction. Okay, here I induced is what? Clockwise. Understood? Now it is what? Towards. Towards andre third case. Okay, in case of third case, A is increasing, flux increases. So what happened? The coil will try to decrease flux by producing field which is in opposite direction andre north pole. In case of north pole, we know anti-clockwise direction. Anti-clockwise direction. So easy enough on this one. Okay, see. Okay, I induced will be what? In the anti-clockwise direction. Hope you understood this one. Okay, kindly read this one. You will come to know exactly. Next question is predict the polarity of the capacitor in the situation described by in the given figure. Okay, north pole. Okay, we will stand here. North pole. This will also become north pole. In case of north pole, okay, for example, if this is a conducting loop, okay, this is north pole, okay, by seeing from here, okay, and the observer here, anti-clockwise direction rest of okay. In case of north pole, we know anti-clockwise direction. Anti-clockwise direction andre hengavutte. Okay, this will be if I stand here and if I try to observe this one, this anti-clockwise direction andre how it will be. No, in case of because north pole is getting closer to what? This conducting loop. Okay, I'm standing here, I'm the observer here, and if I see here from here anti-clockwise direction, okay, if I see here anti-clockwise direction andre this. Understood? Now in case of here, this is south pole, okay, this is south pole, okay, south pole andaga, okay, I'm standing here, okay, understood? I'm the observer here, okay? This is becoming what? South pole. In case of south pole, it will be clockwise direction. It will be what? Clockwise direction. How it will be? If I observe from here, okay, this will be like this, clockwise. Hope you have understood this one. Now in both the cases, okay, I am observing here. For me, anti-clockwise direction is like this. From here, if I observe, okay, this will be south pole. If I am observing from here, okay, in both the cases, the current is flowing in the same direction. Therefore, okay, if this is the capacitor, okay, if this is A, this is B, okay, now this will become what? Plus. Plate A will be having positive charges here, okay, plate A will be positive. Hope you understood this one. Plate A will be positive. This you have to be careful when the north pole is brought near the what conducting loop. It will be what? It will be producing north pole here because it will try to repel it. It will try to repel it. Understood? It will try to repel it. Therefore, if I'm observing here, how the anti-clockwise direction will be? Anti-clockwise direction will be like this. Understood? Anti-clockwise direction. Observing from here. Now, if I observe from here, okay, it will be clockwise because this will be south pole. South pole andaga it will be clockwise. Hope you have understood this one very clearly. A plate A will be positive. Next. Predict the direction of induced current in the situation described by the following figure. How? If you bring south pole here, okay, this is south pole. Now to make you very clear, okay, south pole andaga, what will happen? South pole andaga it will be clockwise like this one, okay, like this will be clockwise. The direction of current will like this, like this. Okay, hope you understood. I am the observer, observing from here, clockwise. Okay, so try to repel it, south pole, This will be clockwise like this. Hope you have understood. Next problem. Consider metal ring kept on a horizontal plane. A bar magnet is held above the ring with its length along the axis is held above the ring with its length along the axis of the ring. Okay. If the magnet is dropped freely, the acceleration of the falling magnet more than g equal to less than. This is a magnet, North Pole. Okay. What happens here? Okay, North Pole andaga, okay, there will be what? Induced current. Understood? There will be an induced current. What happens? The direction of current will be what? How? In case of if this is North Pole andaga, okay, this will be what? Anti-clockwise direction like this. Okay, there will be induced current. Understood? There will be induced current here. Right? Now, this induced current, okay, will apply mechanical force on this magnet. This force will be upwards, F. This is mg, okay, force due to gravitation. And this is acceleration of the what? Magnet. I have written here to make you understand. Due to change in flux, induced EMF is developed. Okay, induced EMF is developed. If coil is complete and made up of conducting material, then I induced is developed. I have shown you I induced is developed. Understood? Now, what happens? You can apply what? Newton's laws of motion. Newton's laws of motion you can apply. How to apply? See, it is accelerating downwards. Okay, चलाने वाला, okay, force, चलाने वाला force minus रोकने वाला force, like that you can remember in Hindi. Okay, ये वाला force is equal to mass into acceleration. Okay, mass into acceleration. Okay, चलाने वाला andre in the direction of what? It is in the direction of acceleration. In the direction of acceleration of ಇದು. रोकने वाला andre opposite to direction of what? Acceleration. Which is चलाने वाला here? चलाने वाला is mg. Okay. रोकने वाला andre f. Okay, is equal to mass into acceleration, m into a. From here you can simplify for a will be equal to what? G minus f by m. Therefore a is less than g here. Acceleration is less than acceleration due to gravity. A is less than g. Hope you might have understood. Students, if you like this video, kindly share with your friends, subscribe for my channel, like it, and ask doubts in the comment box. Thank you one and all. I wish you all the best.